Hello, good afternoon. So today I am going to give a talk on JIT compilation attacks on the iOS. So obviously I am being introduced, so I should skip this. So the agenda of today's talk is related with, firstly I'll explain about the iOS architecture and its security mechanism. Then I'll start with the basics of JIT compilation, then different attacks which are there in JIT compilation, and few case studies like the vulnerabilities which are being present there, and CVs. At last I'll discuss about the mitigation techniques, and then I'll conclude with if anybody will be having any questions. So let's start with the iOS architecture, and in iOS we have 4 different layers. First one is the Cocoa Touch layer, after that is media layer, third is core service, and at the very bottom is the core OS layer. Now from the diagram we can see that from the hardware perspective, the recent layer which comes to it is core OS, which basically he handles most of the kernel related stuff and system configuration which are related to managing the hardware components like the cameras and all different components which are present. Above that is core service layer, which has a main functionality related like SQLite, core foundation, code location, core motion. These functionalities are mainly used in any mobile, or like if we are talking specifically on the iPhones, like the touch screen capabilities and the motion sensor, all those things are managed in this particular layer. Above that is the media layer. Now in this particular layer, as we all know that iPhones are known for its media capabilities like the audio, video and animation. Those things are managed in this particular layer. Above that is the Cocoa Touch layer. This is the layer which is mostly used by the developers who develop the iOS application. So it contains a UI kit and basic game kit and message UI, all those drivers functionality is which are basically like the GUI of the application and all those things. Now there must be one query that why for understanding any compilation attack, the understanding of architecture is important. So there are multiple reasons to learn about the architecture of any operating system. Of many I am here telling 4, and the first 2 are main point of concern and for to remain in the scope of this talk, which is optimal performance and security and privacy. Now why the performance is important? Because once the application is being deployed, and especially if we take the scenario of the Apple ecosystem, they are more geared to, they more market themselves towards the best performing device which is available in the market. And when we talk from the performance point, from the developer's point of view, the performance also depends on how the compilation is being done for that application. And there are 2 basic types of compilation. One is ahead of time compilation and other one is just in time compilation. From name itself, it is pretty much clear that what is ahead of time and what is just in time compilation. But I'll be giving some point of different to some points to differentiate between those. So in ahead of time compilation, once a developer writes the code, developer compiles code, and after the code has been successfully compiled, they use that build to move it in the production, and maybe like in publishing it at the App Store or any other place they want it to. Whereas in just-in-time compilation, the executable is created, but code which is being written is being compiled at the time of execution. Now, from this above point which I mentioned, and it is pretty much obvious that if code is been already compiled and it is there for use, so the startup process would be faster, because at the time of loading, the operating system knows that how much memory or what all things are required by this particular application. Whereas in just-in-time compiler, obviously things would be slower in comparison to ahead of time compilation, because at the time of execution of a code, it would be checking that which all variables are there, how much spaces are required by that variable, and all those things. And from the second point and the first point, it is we can deduce about the third point, that in ahead of time compilation there are less chances of runtime attacks, because the code is already compiled, the possibilities of making such attacks are already reduced. But whereas we talk about just-in-time compilation, these attacks will increase. The chances of these attacks will increase, like the code injection or any such code like arbitrary code execution. Now, there is another thing, like we all from these points, we all can understand that the JIT compilation is not good when we talk from the performance or from the security perspective, when we compare it with ahead of time compilation. So keeping this, mainly this thing in mind, the Apple iOS team do not allow any third party developer to compile their code for the production in the just-in-time compilation. They only keep it for themselves. So mainly like the Safari browser or a few of their applications only uses just-in-time compilation. And also like from iOS version 14.2, they have allowed developers to just at the development stage, they can check if their application have like for the development stage they can use just-in-time compilation, but when they want the production build, so they need where they need to send it at the App Store or at the final build, it must be AOT compiled. Now from the talk which I have given as of now, it must be pretty much obvious that what exactly is JIT compilation doing. Now here is another thing, like why this despite of having so much of issues, why this JIT compilation is a good way, why iOS themselves are using. So one of the thing is like the speed. Now this speed is in terms of while the app is being used. Now we all know that iPhone every year launches a new model, and each new model has one or two new feature compared to the previous generations. Now suppose in the latest iPhone they made dynamic island for everyone. Now, if any application they are building and they want that a particular application to use the functionality of a dynamic island, so they can tweak the code in such a way that only the pro models of 14 and 15 and the normal models of 50 are only JIT compiled, which is using this particular feature. So this will enhance the speed for their entire set of devices which are running all different versions. Yeah, so the next thing is like in JIT majorly the iOS uses it for the JavaScript execution on the web browser, and like we all know that Apple has its own web browser Safari, so they mostly use it for the Safari, which makes the interpretation of code much more faster. Now let us understand this JIT compilation from the context of JavaScript, from the Safari JavaScript engine. Now we all know that modern day applications are mostly built upon JavaScript, and they are using Node.js framework. Now in this Node.js framework, it has its own JavaScript engine, but Safari uses its own JavaScript engine, which is called JavaScript core engine, on top of it, so which enhances their performance capability, and they can use the features and the performance which they aim to serve to their audience. Now since they are using this JavaScript, and they have created their own engine to work on top of it, so obviously it is, we can say that this Safari is heavily dependent on the JavaScript and all this JIT compilation stuff. So now let us look at different vulnerabilities which comes under this JIT compilation attacks. So one is JIT spring, another one I'll be discussing about bypassing ASLR, next one is type confusion, and the last one would be a de-optimization attack. Now few years back, we all must have seen there was one bug in the WhatsApp application where a user can send one Indic language character which was not interpreted or understood by the WhatsApp server, and which led to crash the entire Android operating system. We can understand this particular JIT spring attack in the same particular way, where an attacker can craft an special input which is not interpreted by the JIT compiler, which is used in JavaScript core engine. So it can crash the memory region for the iOS. Now this attack is especially possible in the Safari browser because it is, as I told, that using heavily. Next one is bypassing ASLR. Now ASLR stands for address space layout randomization. So what the Apple and iOS or macOS team does is it randomizes the address in the memory so that the attacker are not able to know what are the memory address present in it, and they cannot perform any such attacks on the memory. But if an attacker can get the memory address from the JIT compilation, there could be the possibility that attacker can get access of all the memory addresses which are being present. We all have seen this particular meme where the JavaScript behaves very differently for the calculation. Like here there is one specific example where the integer 9 adds with the character 9 gives the string 91, and all those things. We have seen this, and in daily operations we also find this particular thing. Now this gives us the possibility of one such attack scenario, which is a type confusion. Now we all know that in the programming language, every different data type consumes some bits of memory. Like suppose the integer is taking 2 bits of memory and the character is taking 1 bit of memory. So this can lead to the confusion in the data type. Like suppose there is memory space allocated for the character, but somehow attacker is able to inject some code in such a way that much more memory is being consumed than the designated memory space. So this can lead to vulnerabilities like the privilege escalation or the buffer overflow. Last one is the de-optimization attack. Like while we were studying the computer science at that time in DBMS, we learnt about the normalization. There we were told that for the second or till third degree normalization, the database will optimize the result and would perform much better. But after we will increase the normalization, like the fifth degree or sixth degree or seventh degree normalization we will make, so it will the data will be so atomic that it would not serve any purpose. Same we can compare it with the de-optimization attack. If attacker sends any payload to the JavaScript engine which is basically optimizing whole thing, so that can lead to the de-optimization or destabilizing of the attack, destabilization of the entire system. So that can lead to the various vulnerabilities like out of bound memory access or use after free scenarios. Now there are few previously reported CVEs or 0 days which I have listed here. Now I'll be discussing a few of them in very brief. Like one of them is CV 2020-27930. So in this particular vulnerability, in this particular CV, it was related to JIT Spring, which I mentioned earlier, where it was possible for an attacker to perform a remote code execution vulnerability by passing the unidentified character in the particular lib-type 1 scalar dynamic library, and this attack was both possible in the macOS and iOS. This issue was fixed in iOS version 14.2 for the iOS which was supporting it, and for the older iPhones like iPhone 6 and 5 it was fixed in the update 12.4.9. So the complete payload I have mentioned the link where they have given the complete payload, but here, like, because of the time constraint, I am not performing and demonstrating it. Next is a different set of CVEs. Now these different vulnerabilities were found in these different CVEs were found as a part of Google's Project Zero, and these were fixed in iOS version 13.5 and Safari version 13.1.1. Now in these particular different vulnerabilities, the memory corruption and the logic issues were identified with the improved state management. Now, why these understanding of the JIT compilation is important? These things are important to understand because there are more than 1 billion of active iOS devices. Now, as in the previous talk, they told that the iOS is not just limited to the iPhones. The iPod Touch, and the previous versions of iPad are also using the iOS, and various different other operating systems like tvOS, watchOS, iPadOS. They are also built on the top of the iOS. So there are so many of these devices which, if there is the attack scenario or there is the next 0 day, it can impact a lot of these devices. And from a lot of these devices, we all know that there could be millions of users who are using these devices. So those users' sensitive data, maybe like in the watch, there must be the data related to their health, and in iPhones there must be data related their personal data, or like the business data is stored. That could also be compromised, because in these attacks, if there is privilege escalation, so entire ecosystem could compromise. Next one is, like, we all are seeing that day by day the web applications, the development of web application is getting complex with much more functionalities. So it can also give some potential space where the attackers can find the potential loopholes. and with the last 0 day which I was able to identify was in 2020. So although there's been no 0 day or no major vulnerabilities are identified in last 3 years, but this gives us a lot much more scope to find vulnerabilities on this particular scene, because there are 3 more iOS version been out there since then. Now, what are the impacts of these attacks? Now, from the various different impacts, the least affecting for the Apple would be the unauthorized code execution. But although we know that its severity is critical, but the other impacts could be the data leakage, bypassing security mechanism, performance degradation, and the most important could be the reputational damage, because once any such attack is been introduced to the public that there is some attack which is causing so much of destruction, so the audience which Apple is catering might not be so technical to understand all these things, so that can lead to the reputational damage. Now let me discuss about the mitigation techniques. Now, obviously this is not much of, so the mitigation techniques is it is not much of the thing to discuss, because since we all know that this JIT compilation is obviously used only by the Apple developers only. So telling something to the developers who are working in Apple is not much of the thing, but few points could be enhanced code auditing, restricting JIT execution, and sanitizing validation, because as I discussed, all these different types of attacks which are possible are there because of the attacker introducing any particular crafted payload. Now, there could be few possible topic of research in this particular area. One could be the advanced detection mechanism. Maybe Apple must be using at background that if any attacker is trying to perform any such attack, they are able to identify and fix at very early stages, and that could be the reason that we have not seen an attack in last 3 years. Another one could be ending much more detailed at how exactly just-in-time compilation is actually working. Another one could be the system analysis, how this JIT compilation is affecting other iOS systems, maybe is it affecting the alarm or stopwatch or the clock, how is it affecting, or if attacker is able to make any attack from the Safari browser to other such components. And last one could be the alternative compilation technique. We all know the advantages of AOT and the advantages of JIT. Maybe there could be some way that we can use the capabilities of JIT along with the AOT. So that was from my side. Anybody have any questions? So I'm open for it.
Any questions? Okay, thank you Shubham for an insightful talk.
Thank you.